Imagine for a moment that your next experience ordering fast food goes something like this. Pulling into the drive-thru at a MAAS Burger, you begin to contemplate the decision between bacon or no bacon. As you wait your turn, you notice an arm begin to extend out the driver's window of the car in front of you, placing their order. Only that's no credit card, it's a middle finger. Someone's not happy. As you pull forward to place your order, you notice the menu has been replaced by a JIRA intake form. Hello, sir. What's the description of your problem today? Excuse me. Why did you come see us today? I'm hungry. Could you please supply the business justification for this request? Huh? What in the world is going on here? Do you have a supporting director for this initiative? What would you say the level of severity is for this request? I'd say it's quickly becoming more severe. Sir, if I can direct your attention to the screen from really happy face on the left to very unhappy face on the right, which one would you say you are? I'd say I'm moving with breakneck speed to very unhappy face. Now, I can't speak for you and your company, but what I can say is that very unhappy face is the experience that we're currently offering our customers, and that's something we'd like to change.
Hello from the Seattle area. This is Joshua McClintock with T-Mobile. I'm guessing most of you enjoy the convenience of being able to pull into a drive-thru and have food waiting for you at the next window in around 5 minutes or less. I know the title of my talk uses the adjective large scale, but anything done at a large scale was first designed at a small scale. That's the stage I happen to be at with the current project I'm working on, which is to deliver the fast food or cloud-like experience for application teams which consume bare metal servers. If you work at a large company, chances are that you have certain policies and standards which must be applied to each system you build. Furthermore, you likely have external systems such as IPAM, DNS, or a CMDB, which must also be updated when building these systems. It's just not an option for you to allow your customers to build systems without enforcing company policy. First, what problem am I trying to solve? Well, this is what my customers with the very unhappy faces are saying. The time it takes to get my servers is too long. We're talking weeks to months, and even in some cases years. That's a big problem. So maybe I could try to copy the drive-thru business model, or at least use some of the concepts and bring them to the world of server infrastructure. But maybe I'm getting ahead of myself a little. Let's first analyze the problem. It takes too long to get my servers. Initially, I thought that if we could automate the installation of the operating system, we'd save a bunch of time. As it turns out, that's a very, very small part of the overall problem. When I finished my analysis, what I discovered is that in our business, we basically have two major stages. The first are all the things which need to happen to purchase, ship, unbox, rack stack cable, and do the initial switch port configuration. The second are all the things which need to happen when someone wants to deploy an OS and application onto one of these servers. In my case, I thought it would be more important to handle stage 2 first, and what was discovered there would inform the changes that need to be made to stage 1. The ultimate goal of automation is to push left in any process you have, eliminating manual toil along the way and inserting API calls where possible. This area between stage 1 and stage 2 is where many tickets get opened and much frustration occurs. Turns out this area is what generated a new request to our network automation team for an API endpoint to change switch port configurations on demand. Without this functionality, this offering would be dead on arrival. Changing tickets into automated processes could be one of the highest hurdles you face. Fortunately, many of our teams are moving their processes into API accessible formats, and this is all important. All systems, IPAM, DNS, etc., that must be interacted with to complete a server deployment must be accessible programmatically. If you're responsible for a system which other parts of the organization are required to interact with, and that system is not accessible by API, it's highly likely that it's negatively impacting the business. If you do have an API accessible system, providing real-world examples of how to use it are invaluable. Tools like Postman can be used to develop collections of commonly used calls that can easily be shared with others. The takeaway is this: trade your tickets for API calls. Before I get into specifics about this self-service implementation, I'd like to position what it is I'm trying to accomplish using this graphic. On the far left, you see on-premises. This is old school infrastructure. As you move further to the right, the cloud provider begins to manage more and more of your infrastructure to the point where an application team isn't even on-premise anymore. They've gone off and started their own darn company, like ServiceNow or Salesforce, where you consume their service from your web browser. Now, I'm not looking to do that. What I'm looking to do is to provide an on-premise cloud-like experience for ordering physical or bare metal servers with the OS installed, IP assigned, DNS name registered, and all the business policy applied. So I'm probably somewhere in this area. Okay, based on some constraints I have, what technology do I need to make this happen using hardware just like or very similar to what's already being used in the enterprise? 1U to 2U big name OEM servers with lights out controllers. I ran across Canonical's Metal as a Service, did a POC with it, and haven't looked back since. It does many of the things I need. Through its API, I can pixie boot a server, deploy an OS, configure the NICs, and provide an IP address, among other things. The only thing it won't do for me is enforce all of the standard business policy and processes we have here at T-Mobile. But I can write that myself and put it in front of this product. During my research, I talked with procurement to ask them who in the company consumes the most physical hardware. As it turns out, it was actually the org I belonged to. I started interviewing the various teams, collating the hardware requirements. While they had some variation, I took the more demanding use case and made it the default for the hardware we'd purchase. Usually you don't get too upset if the cheeseburger you just ordered came out with 2 patties for the price of 1. The last thing I want is for customers to walk away from the offering because the hardware won't meet their needs. Today, we're not able to do true build-ahead. The reasons are manifold, but I think all of them can be boiled down into one statement, which I'll grant you is a bit of an oversimplification. There are simply too many opinions. Worse than that, each one of these opinions over the years have shaped business processes to fit those opinions. This means we have many different ways of doing the same thing. If the application team decides to do something different with this hardware, well, because the requirements changed, all of that concrete, that is, work already done, such as labeling cables, changing switch port configurations, etc., has to be jackhammered, pulled out, and repoured, potentially adding months to the process. That's silly, you say. What application team changes their requirements 3/4 of the way into a server deployment? Application teams largely don't have the vested interest in talking with one another, and all are ordering hardware to meet their specific needs, and in the process are creating supply chain problems and introducing operational inefficiencies, preventing the infrastructure teams from being able to provide true build-ahead. On the flip side, the infrastructure teams aren't giving them much of a choice. The beauty of a self-service platform is that application teams don't really need to know many, if any, of their requirements. The offering should be able to provide any combination of requirements at deploy time. If they don't like what they just deployed, release it and try again. This will enable the application teams to do fast prototyping, which may lead to greater innovation and lead to less fear about giving up resources, since now it takes hardly any time at all to acquire and deploy new servers. This offering will be highly opinionated, but will deliver servers in under an hour from request time. The speed of the solution combined with highly spec'd hardware should be enough incentive to change the application team's behavior from continuing the potluck free-for-all we have today to consuming this well-curated, on-prem, cloud-like offering. This represents a failure domain in a data center. It's a row of 15 racks. This domain has all of the common networks plumbed into it. It's also populated with all the hardware to cover 80% of all the use cases we have. The idea is that the entire row or domain can be lit up with the MAAS offering and provide our application teams with the ability to prototype to their heart's content. Then when they're happy, simply deploy as production. Most deployments should take less than 45 minutes and can be done massively in parallel, approximately 300 plus nodes at once, just in this domain. When we have 10 to 20 domains, the numbers would be in the thousands. In this graphic, Canonical's MAAS product is represented by the box in the top right corner. The custom piece of the solution labeled MAAS Orchestrator is on the left and currently consists of several microservices. The customer's request will first come in through the orchestrator on the left. The orchestrator will make the call to Canonical's MAAS to acquire a free node. It will take the IP MAAS assigned along with the node's data center host name and register those with an external IPAM system. Once that call is successful, it will call an external system to generate a new host name that the application team will know the system by, and register that name and the same IP from the earlier step with DNS. Next, it will create a new stub record in our CMDB and link that record with the physical asset record. Once this is done, the acquired system will then be deployed with the OS the customer chose, along with cloud init user data generated by the orchestrator to prepare the local storage RAID configuration and install our desired state agent. Once the node boots into its OS for the first time, the desired state agent will start up, query the CMDB for the newly created stub record, which will inform it as to what application and role this node belongs to and run the appropriate code. The important takeaway is that you should buy what gets you most of the way and build what's left. Could we have written a piece of software to do what Canonical's product does? Maybe, but it would have taken us years and probably wouldn't have been half as good. So let's see what a little ingenuity combined with Canonical's MAAS can do. What you're about to see is an early stage demo of the MAAS Orchestrator as it was a little over 2 months ago. This is the video I used internally to market the idea and gain traction. If a picture says 1,000 words, how much more so a video?
Hello, my name is Joshua McClintock. I'm currently an MTS in Systems Design Architecture, and I'd like to introduce you to Metal as a Service, hereafter referred to as MAAS, by performing a quick demo of some of its capabilities. What is Metal as a Service? It's the cloud experience for physical hardware. Based on standard sizes and capabilities such as small, medium, and large, an application team could place an order with an API call or web page submission and receive their servers within an hour. OS installed, configured, and reachable by DNS hostname or IP address. It's the fast food experience for physical server ordering. I'm going to demonstrate ordering 30 servers with ESXi installed. Then I'm going to release them and order those same 30 servers again, but choose to have them installed with Red Hat 7 instead. You'll notice 4 different types of windows on my screen. Starting in the top left, you'll see a window running Postman, which is a common tool used to interact with websites and APIs. I'm going to be using it to interact with our MAAS installation in Titan NPE Pod 10. As we move to the right, you'll see a window running a browser connected to ResQ, an open source queuing system developed by GitHub. This MAAS instance is currently idle and has 50 workers just waiting for new jobs to be submitted. Directly below the ResQ window is another browser open to Canonical's MAAS product, which forms the foundation upon which this offering is built. You currently see 46 machines total, with 30 in the ready state. Lastly, all of the little green windows, which are virtual consoles, to 12 of those 30 physical servers which are in the ready state. In other words, if you were to walk into the Titan data center and plug a monitor into these servers, what you see in the little green window is the same thing you would be seeing on the monitor you just plugged in. Let's begin by querying the API's menu endpoint to see what's available. We can see that hardware and operating systems are valid endpoints. Let's check out hardware first. It appears we have one server type currently available with the name or tag of IaaS Dell ESXi.
This is what I've arbitrarily called this server spec. There is currently a total of 46 servers spec'd like this in this particular MAAS instance. Only 30 of them are ready, 0 are deployed, 16 failed. They have 72 cores and 768 gigabytes of RAM. They also have a small boot disk of 16 gigabytes with two network interfaces, EN01 and ENP59S0F0, currently connected to switches. Overall, this is a fairly large server, but with very little local disk space. It'll likely be connected to SAN, which makes it great for virtualization workloads. Now, let's look at the available operating systems. This MAAS instance supports ESXi 6.7, generated from the Dell OEM ISO, Ubuntu's Bionic release, and Red Hat 7. Next, let's look at the subnets that this instance has available. It looks like just one subnet. It appears to have many IPs available and is on VLAN 504. What if we wanted a little more information about the switch ports that a particular server is attached to? In this case, the one with the unique ID of MXTCGE. If you remember from earlier, we saw that this hardware had two network interfaces, EN01 and ENP59S0F0. This is telling us that for this particular server, EN01 is plugged into switch on port Ethernet 1/10, and that interface ENP59S0F0 is plugged into a different switch on port Ethernet 1/10. We even see the MAC addresses for the interfaces and for the switch ports. Alright, with that short tour over, let's use some of the information we've already discovered to order some servers. We're going to be sending a request to the deploy endpoint. We're going to be requesting the server type IaaS Dell ESXi. If you remember, that's the large one with the 72 CPUs and 768 gigabytes of RAM. We want 30 of them with ESXi 6.7 installed. We'd also like those two network interfaces bonded on VLAN 504 with an IP address from the subnet. Now that we've submitted the API request, jobs will be created and placed on the queue. The workers pick them up and begin processing them. You'll also notice the ready number begin to decrease as servers are acquired and transitioned into the deploying state. You'll also notice the little green windows will begin to change as the platform instructs these servers to power on, boot up, and begin the installation process. Once all 30 jobs are submitted, the API call returns some important information which we can use to watch the deployment. Each deployment has a parent UUID. This can be used to query the status endpoint. We're now going to copy the parent UUID and then switch to the status endpoint, paste that parent UUID in, and hit send. This will allow us to view the current status of the deployment. The status endpoint may be used by application deployment teams to know when the deployment is finished and to retrieve information associated with their newly built servers. While the version of the API in this demo doesn't show the server's IP addresses, the latest version does. This data is standard JSON and can be read in by tools such as Ansible or Bolt, which could then perform post-installation configuration steps. I'm now going to fast forward about 10 minutes. For those of you familiar with the ESXi boot process, you'll see that it has been deployed and is now booting up on many of the nodes. Since in this demo we can't get the IP address information from our API, we'll get it from the MAAS webpage and see if we can use it to log into one of our servers. Well, it looks like that worked. We were able to log into one of our servers. It appears that the deployments are all now finished. You can see that the workers are now 0 of 50. The next step is to release all of these nodes and redeploy with Red Hat 7. Now that all those nodes are released, let's go back to the deployment API, change it to Red Hat 7, and submit. Now that the Red Hat 7 deployment is underway, I'm going to speed things up to race through the 15 minutes this would normally take to complete. Thank you for taking the time to watch this early stage demo. Our goal is to revolutionize the way T-Mobile delivers physical servers. This is what we hope to present our customers with when we're done. A catalog of curated items to choose from, much like what you'd see on a menu. Your customer just wants to order combo meal number 1. They really don't want to have to worry that mayo won't spread if the bun isn't on the latest firmware revision. Let's do our best to automate away our customers' frustration. And perhaps they'll select Happy Face on the next customer survey they get from us. Thank you.
Do you have any personal experience or insight into how MAAS compares to Red Hat Satellite? They seem like similar products, but I'm wondering if you've tried both. So my experience with Satellite is probably somewhat limited. I think last time that I had to interact with it, we were looking at it from a package management or patching perspective. And I'm pretty sure that Red Hat Satellite has grown since then. So there's probably some overlap there with deployment features and things that aren't just packages, but physicals. But yeah, I wish I could answer your question a little bit better there. I just don't have enough up-to-date experience with Red Hat Satellite. Someone else says, were there any light bulb or eureka moments during your research for this project? Well, kind of like I said in the video, I really thought that the OS installation time was probably where we were going to save a lot of time, and then it turns out that it's just simply not the case. Installing the OS makes up a very, very, very small portion of what it really takes to get a bare metal machine from powered off to on with OS, and then get it registered with all your external systems like IPAM and DNS, so on and so forth. And so yeah, I guess that maybe was a bit of a shock to me. I thought maybe it's gonna be more of a slam dunk, but it's turned out to be quite a bit more work since we're just not allowed to have our users deploy systems kind of wild west style. There's a lot of policy and security and agents and so on and so forth that have to go on these machines when they come out the other side. So a platform like OpenStack or Amazon is great, where you can do user data so that customers can customize their stuff after deployment. The problem for us is that it's not that we don't trust our users, but we can't trust our users to do the right user data stuff
to apply all the policy. So this is why I had to, create this thing that I, called the MAAS orchestrator that customers actually have to talk to, and then it controls and ensures that all the policy and things like that get applied. Someone else here says, does MAAS have edge applicability? I think it does. We actually have an internal use case. It's actually a separate team from the one I'm working on that was thinking about using MAAS out at the edge. And I'm not sure they're still going to use MAAS at this point, but they were looking at it for that kind of use case. Maybe there's some more detail that you'd like to provide, but potentially, yeah. I mean, if you need to spin up, hosts quick and specifically, physicals. And I think MAAS even has, it can do virtuals as well. My use case happens to be physical, so I believe it can do physical and has some other, features in it that I don't even know about. So I'm somewhat ignorant, still of what some of this product can do. See, someone else says, great demo, thanks. Apart from the API automation, was there anything notable you found missing from MAAS? Hopefully the product team doesn't get upset. The fact that you can only authenticate to it with OAuth 1 is sort of a challenge at this point. It might be nice if OAuth 2 were supported. The reason I say that is because our CMDB system, which I guess I can't say, only supports basic or OAuth 2. And we would have liked to have done a lot of automation on that platform, maybe even be the front end eventually for this thing in the end. But the fact that that platform can't talk directly to MAAS was another reason why I had to kind of create this sort of middleman, MAAS orchestrator, and then kind of re-export, some of the stuff that MAAS does. So that's one thing. I suppose if I had some time, I could probably think of some others. I think that what has pleased me a lot about MAAS is actually the polish that is on it. By the time I found it, I never had to work with any version prior to 2.3 or 4 or something. So I mean that's a good several years, or 7, 8 years. I think the product's been around a while. So by the time I got to it, it had been pretty well polished. So I'm actually pretty happy with it. Okay, someone else says, do you have to implement network segregation within MAAS, example, to isolate workloads from different departments? If so, anything you can share with us on how to accomplish that? Okay, do I have to implement network segregation within MAAS? Okay, isolate. Okay. I probably want a little bit more color on what you're trying to ask. The challenges that we have with what might be most similar to what you're referring to here are that we have various VLANs, and those various VLANs usually map to specific workloads, probably isn't the right word, but use cases, or some of them are global contexts where, kind of, your run-of-the-mill stuff goes. And then you have other contexts which are more secure, that maybe have PCI data, so on and so forth. And so one of the challenges for us, and this probably isn't really hitting your question, and I apologize for that. But if you notice, one of the slides that I had there with the 2 big circles kind of look like the MasterCard logo, and then sort of the that Venn diagram with the intersection in the middle. One of the challenges for us was trying to remove manual human process when the switch port configurations take place. And so how those are connected is, well, the switch port configuration controls which VLAN switch ports are on, and that controls what context that node happens to be in. Now, one solution could be, well, why don't you just tag all the ports with all the VLANs? The security team probably wouldn't be happy with that. Anybody that has root on one of those physical systems could potentially start snarfing traffic, putting the interfaces on VLANs that they're not supposed to see. So this is sort of what prompted us to ask our network automation team to create us a switch port API that would allow us to, at deploy time, say, hey, this physical node should, we know the switch it's on, we know the port it's on, we know its MAC address, all this other stuff. So we'll pass all of that stuff to you in an API call, and you put this port on this particular VLAN at deploy time. So that allows us not to have to tag every single port with every single VLAN. We can just request it at deploy time. So I apologize if I didn't quite answer your question. That's sort of the network isolation we have to do. Maybe you could follow it up with something more specific. Okay, someone else says, did you have any issues with CMDB integration? Yes. The answer is definitely yes. The first one is, that authentication problem. So we kind of, got around that by having this middleman thing that I kind of already had to have. So I guess that's kind of solved. The other things are that CMDBs in their life cycle, at least for us, go through different phases where server records or whatever, and all your application records and this sort of thing maybe are changing models. I think we're having to interact with the common service data model these days. So a lot of code that was written to interact with the CMDB is now having to be changed or rewritten to accommodate these changes that happen in that system. So that can be kind of frustrating. So yeah, hopefully that answers your question there. So yes, CMD integration can be frustrating. Now, if you don't have, if your CMDB is not API-able, which I can't imagine there's one out there that is like that, that would certainly be a complete non-starter for me. Okay, someone else says you mentioned deployments, DNS registration of, and are starting to talk about switch ports. How about automation of dynamic virtual network security groups? Yes. So on my slide, I think we mentioned firewalls potentially. So when an application team goes to order some hardware, it's not hardware they're ordering. What they're ordering is kind of a ready done platform, a bag of burgers, that has fries and a drink and stuff waiting for them at window 2. And part of that is that the firewall is open for their particular use case. So we do have efforts underway, and actually this is another CMDB type integration. I believe that firewall groups would be created sort of at an application team's enrollment, onto the platform. So it'd be kind of like some one-time setup when application teams would want to consume our platform. So we asked them, what's your use case? What ports is your thing going to use? And so once we know all that information, we would set up something like a firewall group in the appropriate place. And then at deploy time, we would just add the nodes that we just deployed to that firewall group with the goal that those ports would be open, at that time. Okay, someone else says, which configuration management tools are you using with your setup? Example, Juju. So if I'm understanding Juju correctly, Juju is largely kind of a, like it would be something like an application team might want to use to interact with MAAS directly. So unfortunately, as I said before, we can't allow customers to interact directly with MAAS. We have to have something in front that can enforce all of the policies and so on and so forth. So you might respond and say, well, I mean, can't you just somehow use Juju for that? Maybe. I don't know Juju that well. I also don't know all the things that it does. And maybe it's similar to Terraform. If I'm sort of making an apples to apples comparison there, Again, Terraform is and Juju and tools like that are great if you can sort of allow a wild west, you know, in your environment. Kind of like AWS, you know, right? Nobody tells you what you can or can't do on AWS. AWS is not going to enforce policy. They're just you know, provide resources and you come and utilize them. We just aren't able to do that exactly. There's just too much policy and process that has to be enforced. And so unfortunately, we're a little bit more locked down than that. So yeah, hopefully that answers your question. Yeah, we do have a desired state agent that will you know, do like infrastructure as code or desired state, you know, as code. That might be the closest thing to Juju, but that really happens at a later stage in the process. That's once the machine is up, OS is on, it can talk on the network, you know, that desired agent, you know, would take over. Okay, well, that looks like the last of the questions. If anybody has anything else, be happy to answer, but well, that might be it.